All right, so let's graph some polar equations, and we're just going to do some very, very basic ones. An equation expressed in terms of polar coordinates is called a polar equation. And so an example of one, and this is a little more complex, is r being radius equals 2 sine theta. That's a polar equation. A polar graph is the set of all points with coordinates r and theta that satisfy each given equation. And so again, we're just going to look at some very, very basic ones, very similar to having an equation that says like x equals 2 or an equation that says y equals 7. That would be what I would say is similar to as far as a rectangular coordinate system goes. All right, so for this guy, it says that we want to graph an equation where the radius is 2, but you'll notice it doesn't give us anything about the angle. We don't know what that is, so that means that it could actually be absolutely anything. So if I go out to 2 units from the origin, I'm right here, but since I don't know what angle I'm at, anything is fair game here. So it would be that entire circle. So if I have an r equals equation, it's going to be a circle because I'm 2 units from the origin, but because it doesn't define what the angle has to be, it can be anything. So I go all the way around. For the next one, we have theta, which is our angle, but then we don't know what our radius is. Could be anything. So I'm going to go ahead and find where my angle is at. That's pi over 6, which is right here. But because I don't know whether I'm going out 1 unit or 4 units or whatever, any radius that I give this is going to work. So it's actually the whole ray. So if I have, again, if I have r equals, I'm going to graph a circle. And if I have theta equals, I'm going to graph a ray. Another thing we can do with rectangular coordinates is find the distance between them. And we also have a formula here for distance between 2 polar points. So we have point 1, which is r1 theta 1. And we have point 2, which is r2 theta 2. And you can see those values within our equation where the distance between those is the square root of the quantity r1 squared plus r2 squared minus 2r1 r2 cosine of theta sub 2 minus theta sub 1. So we need to identify those values. And then we can find the distance between the 2 points. So we have an example of using that here if we want to find distance. It says an air traffic controller is tracking 2 airplanes that are flying the same altitude. The coordinates of the planes are 5 and 310, which is A. So we want to find 310 degrees, which is right in here. And then 5 units from the origin. So we've got 1, 2, 3, 4, and 5. So this is plane A, which is at 5, 310. And then we have plane B, which is at 6, 345. So we need that one. So I'm going to measure around 345 degrees, which is here. And 6 units for that one is 1, 2, 3, 6 units. And that is B, which is at 6, 345. So I want to label my points then. I'm going to let this be R1 and theta 1. And I'll let point A be R2, theta 2. So my equation, the distance is the square root of, let's go back up here, r sub 1 squared plus r sub 2 squared minus 2 r sub 1 r sub 2 cosine of, I keep wanting to write Q, theta sub 2 minus theta sub 1. All right, so we just fill it in. And I would definitely have a calculator out to work this out. So for the distance between the points, I've got r sub 1 is 6, so 6 squared plus 5 squared minus 2 times 6 times 5 times the cosine of theta sub 2, which is 310, minus 345, which is theta sub 1. Okay, so we'll do a little simplifying. I'm gonna get this, I can do this product, and I can do this difference. So I have 36 plus 25 minus 60 times the cosine of negative 35 degrees. And so I should be able to put all of that in my calculator and get an approximation. So just like that, I'm going to do the square root of 36 plus 25 minus 60 times the cosine of negative 35 degrees. We just want to make sure that your calculator is in degree mode because we entered degrees. And our result is about 3.44 miles. So that's how far they are. And what this is really doing, I mean, part of what we would be trying to do at some point is think about what the coordinates of the curvature of the Earth as well. All right. That's all I have for you. I know it seemed like a lot of talking there, but hopefully you have a good idea of what polar coordinates are, and we have a small homework assignment to go with this. Have a good day. Bye.